All right, so I guess we'll get started. It's a little bit of a light crowd today. So first things first, I'd like to apologize. I started coming down with a cold, in June. So if I'm a little sniffly, bear with me. And if I say anything too crazy, I'll just blame it on the Dayquil. So who am I? I'm Chris Czub, a security engineer at Duo Security. I work on our corporate security team. So yes, Duo does have a security product, but no, I don't work on that. Our team is responsible for building engineered solutions for internal security. What I'm going to talk about today is how we did OS X application whitelisting across the company, how we rolled that out, and some of the supporting architecture and applications we built around that, and how you could do something similar. I hope to kind of start a discussion with this and get people thinking about how we can do application whitelisting in a better way for our employees. So who here is in a blue team role? Can I get like a show of hands if you're a blue teamer? Okay. Do you have OS X fleets? Cool. Okay, yeah, so like one person might find this interesting. Just kidding. Even if you're doing Windows stuff, you might take some inspiration here. Like we are rolling out App Locker for Windows. We have a handful of Windows machines. We are largely Mac. But we're going to follow some of the same principles when we roll out for App Locker. So, like I said, we have a huge OS X fleet. We have about 600 OS X machines. I mean, I consider that huge. That's 600 OS X machines and like 10 Windows machines. So we're very biased towards OS X at Duo. I'm going to talk a little bit about our motivations for adopting application whitelisting and how we designed our system, the considerations we put into that, how we rolled it out, what our experiences were, things that we learned. We don't know all the answers here. We kind of want to have a conversation with you and figure out what other people are doing and how we can all improve. So one of our philosophies when rolling out internal security, particularly endpoint security, is to try and build guardrails, not gates. So we want things that are more like guardrails and traffic cameras so we can get insight into what's going on and gently guide people in the right direction, but they can still bypass it if they need to. We don't want to get in people's way too much. So we don't want to block people from running the software that they want to run. We don't want to make it so someone can't get their job done. We just want to allow them to think for a second, allow our security team to get some insight into what's going on in our environment and be able to see if known malicious software is running, mitigate things as we deem fit. So, overview of application whitelisting, why we are using it. We need to have an anti-malware strategy for our endpoints. We can't just throw our hands up in the air and do nothing about anti-malware on our endpoints. So we realize that application whitelisting is one of the most effective ways that you can do that, but it can also be a nightmare to deploy without annoying your users. Who here has rolled out application whitelisting? And how did that go? Yeah. So we wanted to be able to cover the vast majority of off-the-shelf malware with the least expense. So things like people clicking on fake Flash installer banner ads and installing crapware are really what we're trying to stop here, just things that would clog up our analysts otherwise. We want to be able to leverage threat intelligence sources like VirusTotal to be able to enable detection after the fact so we can see that, oh, this hash ran on a machine and now it has detections. Well, we can see that it ran on this machine, so we can have our analysts help to remediate that. So there are two concepts. There's whitelisting and there's blacklisting. Whitelisting implies that only applications that you specifically allowed to run will be allowed to execute. On OS X, they have a signing chain, so applications can be signed by developer certificates. You can also whitelist on a per certificate basis. So if people are using a lot of Adobe software, for example, you can just whitelist that Adobe certificate, allow the whole Adobe suite to run. The reality on OS X is that a lot of binaries that people are distributing aren't signed, so you wind up having to sign individual binaries, and we'll talk about some of the challenges with that. And they've recently added package-based whitelisting to our whitelisting solution. I'll talk a little bit about that later. So I'm going to go over how this looks in practice, how our application whitelisting looks to our end users and to our analysts. So a Duo employee is on their machine. They find some application that they want to use to do their job. They go to whatever website they get it from, they download it, they install it. That's all fine. Usually our application whitelisting won't hop in there because those are just like shell scripts that are running in the post-install files, and we don't do anything about that. So could you like install a malicious package and drop some persistence there in the installer? Yeah, probably, which is why we use other solutions to defend against that, like OS query, to monitor persistence locations on machines. Anyway, so they install that application, they double click it to try and run it, and they get a pop-up saying that Santa, which is our application whitelisting solution that we've chosen, has blocked its execution. That pop-up contains pretty much all the information that our upstream systems will receive about the blocked application execution. So it has things like the file name, the path, that whole signature signing chain, the hashes of the certificates, and the binary itself. And then a couple seconds later, the user will receive a message on Slack. So we developed a security bot in our Slack that we use to communicate with people. We're big fans of doing chat ops at Duo, and we apply that to security too. So we have our own security-centric Slack bot that communicates with users about security events. So here, users will receive a message from the security bot saying, hey, we saw that you tried running this application, it was just blocked. It gives them a little context about what that application it saw being run was, directs them to a support channel if they have any questions, and then gives them a prompt where they can say, yes, I want to run this, or no, I don't. So if they select yes, they get this message from the bot saying, okay, it's been whitelisted, and then within about 30 seconds, their machine will sync the rules and they'll be able to run the application that they were trying to run and get on with their day. Again, we direct them to the support channel if they have any questions. And the way this works is that it adds it to a per-user whitelist for them at that time. So it doesn't mean it's whitelisted for the whole company, it's just whitelisted for them. And it did do some checking against threat intelligence sources, and I'll go through the whole flow of that later. So a couple months after we developed this, Google released their own backend server for Santa. So Google developed Santa, which is the whitelisting solution that we're using. And they released it, and on its own, it doesn't really do much for you. You need to have a backend server for it. So we developed our own server for it. Google released Upvote a couple months ago. And here on the left, I've kind of taken what they have on their GitHub page about it. So it was written with the Santa development team, so it's very tightly integrated with it. It does have kind of a heavy reliance on Google Cloud stuff, which we are more of an AWS shop. So like it relies on BigQuery and stuff. It's kind of cool. It does support bit 9 if you're doing Windows stuff. Again, it does user-oriented policies rather than machine-based or fleet-based policies. And it has support for package whitelisting and the same kind of like virus tunnel integration that we did in our solution. But the way that theirs works is that users vote to have something whitelisted. So you can set a threshold for a number of votes that something will receive before it's allowed to be executed on machines. We weren't sure if that would work at our scale, and besides, this wasn't available when we rolled out our solution, but it might be worth looking into. So the reason that we are doing this is primarily to stop malware propagation, and one of the ways we do that is we make all of our whitelist entries individual at first. So when a user responds to that Slack interaction, it's whitelisting it only for them, not for the organization. But we do have a check in there where if a threshold of a number of employees all agree to whitelist that on their machines, it will whitelist it for the company. We figure that that's a good balance of usability for the company versus security, where we figure that more eyes looking at more people making that decision of whether this is good or bad gives someone the opportunity to say, hey, this is bad if there's like mass emailed malware to our company. At least one person will hopefully say it's bad before it gets added to the global whitelist. So some of our results with this, we've whitelisted over 200 developer certificates, over 1,000 binary hashes individually for things that weren't signed, and we look at over 20,000 application launches per week across our fleet. We deployed this all in 4 months. None of us lost our jobs. It freed up analysts and engineering resources to work on more interesting things. We have like a quick automated turnaround now from detection to remediation. So if we detect something bad is on someone's machine, we can push down malware bytes, clean that off of there pretty quickly. So as an aside, I mentioned our security bot. Who is our security bot? It's kind of a mix of all these personas. It's a trusted advisor for our team that represents the security team and security initiatives at Duo internally to our employees. So it provides scripted interactions for them and guides them through things like our application whitelisting. So some things our security bot does is to share security updates. So one thing that the security team does is we put out a monthly security newsletter to the company. So this is a way that we communicate what we're doing in the organization to the rest of the company. We have different functional groups within security. So we have like our research team, we have application security, we have corporate security, and we all have our own concerns. So we present like new research that's going on from our research team, or trainings that the application security team is giving, or new initiatives corporate security is leading, or conference talks people are giving, or just things of general interest to the company from a security perspective. So we share these via the security bot when they come out, so everyone gets a Slack message saying, hey, the new newsletter's out, and they can check that out. Another thing that we do is get user consent to participate in beta programs. So one way that we try to avoid frustrating our users too much is by running beta programs before rolling things out widely. That way we can get feedback from them. So the way this works, again, we define what the beta program is. So we say we have this new feature for Santa automated whitelisting. And then we send them a message saying, hey, corporate security is testing this feature. Would you like to participate in it? We give them a brief description of the feature and a quick yes-no prompt where they can say that they want to participate or not. Their response gets recorded in a database, and then we have APIs to that database that we can use to see in our applications if they're in that group, so we can make changes to the behavior of the application depending on if they're a member of the beta group or not. We also use our security bot to inform users of new features. So for example, we rolled out a password check extension to Google Chrome. We use G Suite heavily so we can enforce that everyone has the same set of Chrome extensions. We require use of Google Chrome to access company assets. So here we rolled out this password check where if they type their password in a phishing site, it'll notice that, and then security bot will message them and force them to change their Google password. We also use it to encourage good behavior from our employees. So here's an example where we detected that a user upgraded their iOS device within a day to a version that had some important security fixes. We send them a message just congratulating and thanking them for doing that. So do you want to do something like this too? Maybe. It's kind of interesting. So there's some infrastructure elements that you're going to need. I'm going to run through those. So I mentioned this a little bit. You're going to need some kind of server-side component to maintain the whitelist and process the events. So this is responsible for having that whitelist and blacklist of binaries and certificates and packages, having APIs for managing that, and also providing somewhere for those Santa events to be uploaded. So this is actually pretty easy to write. You can write in a couple hundred lines of Python. You can use something like Google Upvote. There are things like Zentrol and Doorman that exist that can be used for this. You're going to need some kind of front end for managing that whitelist. So your analysts are going to need a way to add, remove, and search through the whitelist to see what's been previously whitelisted. They're going to need a way to blacklist items that have been added to the whitelist that are now known to be bad. So we have a front end that allows our users to do that. We're trying to build one right now that'll allow them to view the status of the whitelisting application itself to confirm that against what we expect for that machine. We're going to set some alerts up around that too. So things like whether it's in lockdown or monitor mode, how many rules are in the database that are on that machine, et cetera. You need some kind of configuration management to actually get this whitelisting software installed on the machines and configured correctly, to point to the right server, to set to the right mode, depending on what group they're in. And we use Chef for that. You can use whatever works for you. You'll need some kind of orchestration automation. This can, again, just be a handful of scripts or an actual orchestration automation platform. We wound up using Command for it, which I'll talk a little bit about. This handles the interactions with Slack. So basically, when a block event comes in from our server side, it kicks off a job in Command that handles all the interactions with Slack. It makes the API calls back to our server if they choose to whitelist something. It can kick off the Malware scans. And it also creates a trail with all of the data that used to make its decisions, so things like the threat intelligence scans that did. All that data is just captured in kind of an incident format that our analysts can look at later. So it's like one place where they can see everything. If something was detected to be malicious on a machine, they can get context about it really quickly. Then you're going to need some kind of log forwarders too. So you have this backend server processing allow and block events. You're going to want some long-term log storage for that. We're using Splunk for that, as well as a way to send those off to whatever your orchestration platform is. And then something else is a tool to perform periodic checks of that whitelist. So maybe something was whitelisted at one point, but now it's known to be bad and there are detections for it. So we just do periodic Lambda checks across that whole whitelist, run it through threat intelligence, see if anything that was whitelisted is now detected as being malicious. So the first component of this that we're using is Santa. This is open source from Google. It consists of a kernel mode component that basically filters all the exec calls going on that system. It's open source. You can go to GitHub and find it. Though building it might be tricky because kernel extensions on OS X have to be signed, and Apple does not really give out kernel signing certificates willy-nilly. But Google supplies a signed extension that you can just download, install, and use. So here's what they write on their GitHub page about Santa, their viewpoint of it, which I think is pretty important to understand if you're going to roll something like this out. It won't stop all attacks or provide 100% security. It is written with the intention of helping protect users from themselves. So again, it's a guardrail for them. It's part of a defense in depth strategy. It shouldn't be the only thing that you're using for your endpoint protection. We also use Amazon Web Services to spin up all the infrastructure surrounding this, so pretty heavy users of EC2. I think that we might ditch EC2 and switch everything over to Lambda on here and the API gateway. I think it would be a lot cheaper and lighter weight. We use Splunk for our long-term storage and analysis. It's important for us to be able to know which boxes software is running on so that if we do detect something malicious ran on one machine, we can see if it ran anywhere else. If we have some kind of threat intelligence that tells us the thing's going around, we can search our boxes, see if we've seen that hash anywhere. And we use Command as our security orchestration automation platform. It's from Rapid7. Basically, you get a GUI where you can build flowcharts of activities. So we say, okay, a block event comes in, and then we communicate with our threat intelligence system to see if that hash is going to be bad, and then you'll see a little bit more of it later. Those workflows can involve automated or manual decisions at every step along the way, and collect context and store that in the incident so your analysts can look at later. And with all those, we're ready to party. So let's talk about how all this fits together. So here's kind of the flow chart of how this works. We have our application that runs. Santa picks it up. It checks it against the whitelist and blacklist. If it's in the whitelist, it's fine. It just lets it run. If it's not known or it's blacklisted, that's when it hits that backend server that we wrote. So it sends that data over to that backend server, gets logged to Splunk, and then it gets sent over to Command, our orchestration automation platform. And there it does checks against threat intelligence. If it's detected as bad, it'll tell our analysts immediately so they can work with that employee to perform remediation on their computer. If there are no detections, then it'll kick off that Slack interaction we saw earlier where it gives the user the opportunity to choose to allow that to run on their machine. It'll update that whitelist and then trigger what's known as a whitelist sync on their machine to grab the latest version of the whitelist for that user. So I'm going to talk about our deployment strategy for this. So for the first 4 weeks, we deployed Santa in what's known as monitor mode. So monitor mode won't actively block anything except for things you've added to your blacklist specifically. So here it will just collect information on every application that's executing and send that up to that sync server. So everything that allows to run, you get the hashes for, you get the signing certificate chain for it. So we collected this data for about 4 weeks to get an idea of what was running on our fleet, deduped it, found the most common certificates and binaries that were running, and then we used that to generate an initial whitelist for our fleet. So we spent about a week doing this. So we found common signers and binaries and then thought about what we were actually whitelisting, whether it should be whitelisted, ran all that against threat intelligence, made sure it was all good. During that time, we also switched our security team to what's known as lockdown mode, which requires everything that's running to be whitelisted, just to get an idea of what kind of user experience we're going to be putting people through. And then we ran a pilot program, so we used our beta bot to get users across the company to get a diversity of perspectives, got them to opt into our beta program, and then began putting those beta users into the lockdown mode. So that allowed us to get a perspective from the company on how they felt about the system and iron out some of the platform code and the architecture that we were using. The way we originally implemented this, we didn't have the Slack interaction in place. So if something was blocked, it was blocked, and they had to go into Slack and ask one of our analysts to whitelist that for them. We quickly realized that that was not scalable and wouldn't work. It would just create too much of a burden on our analysts. And there were a ton of unsigned binaries running. People would run software updates, and this binary that was unsigned now has a new hash. It has to be whitelisted again. It was just a big headache for everyone involved. So we figured we need to find a better solution than the analysts manually whitelisting everything. So we created that self-service Slack workflow that I showed earlier. We figured that by putting threat intelligence in the mix and only briefly getting in their way and giving them a chance to make that decision, it would have like the right balance of security and usability for our needs. And also we still get the benefit of having that blacklist where we can add things that we know are bad and block those at the kernel level. And it gets us that logging of everything that's run on their machine, so it's really security gain without losing anything. And then from there, we went to full deployment after about 4 months of testing the system. But we're still iterating on this, of course. So one thing that we missed in our self-service flow is using the certificate-based whitelisting features more. So we need to do more analysis of that to find common certificates that are being used by employees. We have some next steps that we would like to do here around the solution. So one thing that is important to me is doing some validation of the system. So we're big fans of OS Query, which, if you're not familiar, provides a SQLite interface to operating system state. You can build extensions for OS Query. So Trail of Bits just recently released this extension for Santa management. So what you can do with this is query the rule database as well as the event database on an individual machine. So what we would like to do with that is just validate that a machine has the rules that we expect it to have based on what the server knows. And we can trigger alerts based on that, because it might indicate someone's manually inserting things into the database or changing it. They also added writable table support, so you can theoretically use this to insert things into the whitelist. I don't know about the utility of that, but maybe you would think that's interesting or useful. We want to make some code and architecture improvements to this. So things like allowing employees to use the bot to view and manage their historic interactions with it. So maybe they want to report something to security that they previously whitelisted and then realize that it's kind of creepy or weird and they want security to look at it, giving them a quick way of doing that. Adding a more generic web interface for the analyst to get management visibility in the system, see whose system is in what mode, and do this all in a web interface that's decoupled from other systems. Right now, it's part of a larger kind of monolithic web app that our analysts use for everything. And then we'd like to convert the system to use Lambda, like I mentioned earlier, instead of EC2, and remove a lot of those interdependencies with our internal systems. Like right now, it relies on command. It'd be cool if you could just give it your Slack API creds and we just write some Python code around it to handle those interactions for you, so you don't necessarily have to have an SOA, but maybe give the option to feed data into that system if you do have it. Then the next step from there would be open sourcing it. That'd be pretty cool. So I'd love to write some blog posts about this and release the code on GitHub eventually. We're not there yet, but that's our end goal with this. So challenges that we had with this solution, rolling this out. The first major one was Analyst Spam. So I mentioned how originally we didn't have that self-service whitelisting. Users had to go to the analyst for everything. It just created a ton of spam. We also had an issue for a bit where we weren't throttling things. So what happens on Mac is sometimes a launch daemon, if the binary it's trying to launch fails to execute, it'll just keep trying to relaunch it in a loop. So it'd create like 100 block events. So we had to add something in there where it'll only send a Slack message to a user about a specific binary once every 5 minutes. Yeah, and initially we were also telling our analysts whenever a user whitelisted anything, and that was just too much noise for them. So you should really only give your analysts stuff that that's actionable and useful to them right now. So it's important to not spam them. When you're doing this kind of chat op stuff, it's real easy to create a lot of noise and just start filling up that Slack channel that they're sitting in. You need to avoid that temptation and not be afraid to kill things that aren't providing them any value. Developers were also a challenge to us. We have a lot of engineers at the company, and rolling out lockdown mode to them is difficult. They're compiling stuff all day, and it's not signed when they're doing it right. Like, they're just compiling some Go application, and then they make a change to a line of code, they compile it again as a new hash. It's just not scalable to have them, even with the self-service, clicking yes and then running it. It's frustrating. So one way that we thought about addressing that is with path-based whitelisting. That's a feature that Santa does support. So we can give them a list of paths where they can keep their code. We still get a lot of the security guarantees out of Santa, and it's better than not having any whitelisting at all. Another option is to just leave your engineers in a monitor-only group, where you'll be collecting information about what's running on their machines. You can apply a blacklist to them of things you know are bad, but you're not requiring everything that runs to be whitelisted. And then unsigned binaries and software updates. I mentioned this a little bit earlier. A lot of popular applications, it turns out, don't sign their binaries, which is kind of lame. And then when they update, they have a new hash. There's no signature of a certificate that you can use. So users won't be able to run it until they click the little yes prompt again. So there's package-based whitelisting. We have to visit that. That's a new feature that Santa added that we haven't explored yet. Basically, on OS X, your applications can be put into packages, and they can contain multiple binaries. So you can say, yeah, this whole package and all the binaries that belong to it are going to be whitelisted. So we're going to visit that as a potential solution here. So lessons that we learned rolling this out. The first one, your users will install bad software. This might come as a surprise to some, like we were on a phone call with a security team at another company just talking about how they do endpoint security, and we were talking like, oh, what do you do for anti-malware? And they said, our users don't install malware. And we were like, what? Like, your users are going to install bad software. Ours install bad software. It happens. People get fooled. People get tricked. Yeah, so you should have some technical controls in place to detect that and be able to remediate against it and know what's running on your fleet. Just be able to get some insight into what's going on your machines so that you're not caught by surprise. We also get that cool cross-fleet blacklisting capacity. Even if you're only running in monitor mode, you're not requiring complete whitelisting, you can still blacklist things. That's pretty neat. Making the security team a trusted advisor to the rest of your company. This was critical for rolling this out to get the trust of the rest of our company, to be able to experiment with new security solutions and iterate on them without them getting too annoyed at us and them realizing that we are trying to work with them and we're not trying to get in the way of their job. We're not trying to be the Department of No. We're trying to give them the right guardrails to help them out and iterate cooperatively with them. So it's for the benefit of the company. Everyone understands that, and our intent isn't to get in their way. Whitelisting bypass is acceptable in some use cases. Okay, if you're running a kiosk and you expect only a couple applications to run, I understand, yeah, you probably should consider whitelisting bypass unacceptable there. But on general purpose machines that people are using to run all kinds of software, it might be acceptable to have whitelisting bypass. Like, it's really easy to bypass Santa if you know what you're doing. You can do things like inject a shared library before you execute it. It doesn't do anything about scripts. Like OS 10 uses Python pretty heavily for management scripts. That Python interpreter is not blocked. You can write whatever you want in there. And our users all have root pretty much. So they can choose to unload Santa entirely if they wanted to. So we use other tools to get insight into that to see like what kernel extensions are being loaded on their machine so we can detect these events when they happen. Just having that record is some valuable data. You should maybe consider monitor mode if you're unwilling to do a complete lockdown. And a little bit of engineering can go a long way. So we're blessed enough at Duo to have this corporate security engineering team who can develop these solutions. And it's cool because it lets us build things that work for our organization and fits our needs. But at the same time, you don't want to over-engineer. You want to just get that minimal viable product together, roll it out to that beta group, get their feedback, and iterate from there before rolling out to the rest of the company. And that's about all that I have. So it's like lunchtime, so you can run to lunch. If you want to find me out there and ask any questions, let me know. Thank you. Thank you. Yeah, we do have some Linux users, and we have to visit endpoint management there. Yeah.